let's get some more practice finding the angle, and in these cases, the positive angle between the positive x-axis and a vector drawn in standard form where its initial point, or its tail, is sitting at the origin. And so here for vector A, we can write it in two different ways. In engineering notation, it would be -2 times the unit vector I, minus, that's the unit vector in the x direction, minus 4 times the unit vector in the y direction. Or we could just say its x component is -2, its y component is -4. And we see that here. If we're starting at the origin, we go 2 to the left, and we go 4 down to get to the terminal point, or the head of the vector. Now let's figure out what theta is. Well, we've seen before that we can, when we're thinking about vectors drawn in standard form, we could say that tangent of this angle is going to be equal to the y component over the x component. So the y component is -4, and the x component is -2. And in the previous video, we explained why this is. It really comes straight out of the unit circle definition of trig functions. Tangent of theta is equal to the y-coordinate over the x-coordinate of where a line that defines an angle intersects the unit circle. And I encourage you to watch that video if that doesn't make much sense. But so we could say tangent of theta is equal to 2. And so we might want to say, if we want to solve for theta, we could say theta is equal to the inverse tangent function of 2. And I'm going to put a question mark, and I think you might know why I'm putting that question mark. So let's see what that gets us. So if we were to take 2, and I want to take the inverse tangent, not just the tangent. I want to figure out what angle gives me a tangent of 2. So inverse tangent, it's about 63.4 degrees roughly. So this gives me theta is approximately 63.4 degrees. And I'm going to put a question mark here. And I think you might sense why that is. If you don't, pause the video and think about why am I putting a question mark here? Why does this angle look fishy? Well, it looks fishy because an angle of 63.4 degrees would put us squarely in the first quadrant. If our vector looked like this, let me see if I can draw it. If our vector, if our vector looked like this, so if our vector's components were +2 and +4, then that looks like a 63-degree angle. This looks like a 63-degree angle. But we're not in the first quadrant. Our vector A that we care about is in the third quadrant. So it's clear that it's in the exact opposite direction. And I think you see why. When we take the inverse tangent function on our calculator, it assumes that the angle is between -90 degrees and +90 degrees, while here we have an angle that's over 180 degrees. It's between 180 and 270 degrees. And so to find this angle, and this is why if you're ever using the inverse tangent function on your calculator, it's very, very important, whether you're doing vectors or anything else, to think about where does your angle actually sit? What quadrant does it actually put you in? Because you might have to adjust those figures. So it's not going to be 63.4 degrees. It's going to be that plus another 180 degrees to go all the way over here. So theta is going to be 180, and I should say approximately because I still rounded. 180 plus 63.4 degrees is going to be 200 and, what is that? 180 plus 60 is 240, so 243.4 degrees. So let's do one more. So here I have a vector sitting in the fourth quadrant. Like we just did, pause the video and see if you can figure out the positive angle that it forms with the positive x-axis. Well, we could do the same drill, and maybe we could skip a few steps here now that we've done it many times. We might want to say that the inverse tangent of, let me write it this way. We might want to write, I'll do the same color. We might want to say that theta is equal to the inverse tangent of my y component over my x component of -6 over 4. And we know what that is, but let me just actually not skip too many steps. So the inverse tangent of -1.5. -1, -1.5. And once again, I get to get my calculator out. And so 1.5 negative, and I want to find the inverse tangent of it. I get roughly -56.3 degrees. So this is approximately equal to negative 53.6 degrees. Did I do that right yet? Oh, 56.3. 56.3 degrees. And once again, I'm going to put the question marks here. And why did I do that? Because the angle that it's giving, and this isn't wrong actually in this case, it's just not giving us the positive angle. Because if you start at the positive x-axis and you were to go clockwise, well, now your angle is going to be negative. And that is negative 56.3 degrees. But we want to figure out the positive angle right over here. So there's a couple of ways that you could think about doing it. One way to think about it is, well, to go from this negative angle to the positive version of it, we have to go completely around once. So we have to add 360 degrees. So if it's really approximately negative 56.3 degrees plus 360 degrees, which is going to be, what is that? So it's going to be, let me write it like this. So it's going to be approximately, so see, if I subtracted 50 degrees, I would get to 310 degrees. I subtract another 6 degrees, so it's 304 degrees, and then 0.3, so 303.7 degrees. Did I do that right? Let's see, if I add this 0.3 to the 7, that's going to get to 304, then to 310, to 360. So there you go. That is our positive angle that we form. So always really think about what they're asking from you, or what a question is asking from you. Well, anyway, you get the idea.